Hello, I am going to talk about sum of angles via Euler's equation. The video will stay the same throughout the entire video. It's just this page of text. At the top, you will see the Euler's equation, e to the I theta equals cosine theta plus I times sine theta, where e is the Euler number, which is about equal to 2.718. I is the imaginary number, and theta is the Greek letter theta that we're going to use as our variable. At the bottom, you'll see the two formulas we're trying to come to, which is the cosine of x plus y and the sine of x plus y. Those are the sum of angles formulas. We're going to try to move step by step to get there. So that next line down, we have now e to the ix times e to the iy. What I've done is I've just copied the Euler formula 2 times and multiplied it by itself with two different variables. So the first part, e to the ix, on the right-hand side of the equal sign has cosine of x plus I times the sine of x. And then next to the multiplication symbol on the left-hand side, we have times e to the iy. Well, then on the right-hand side, I've multiplied by the sine of y plus I, cosine of y plus the I times the sine of y. This is just multiplying the Euler equation by itself 2 times and introducing a couple new variables. On the left-hand side and the next line down, we have multiplied two things with the same base. When you do that, you can add the exponents. So e to the ix times e to the iy would become e to the power ix plus iy, and then I factored the I in front. So it's e to the I times x plus y in a parenthesis. On the right-hand side, we had a binomial times a binomial. Two things times two things. We had to multiply those out. Some people would call it the FOIL method. When you do that, you'll get two terms that have I and two terms that don't have I, and that's how I've grouped them. The two terms that don't have I are cosine x times cosine y minus sine x times sine y. That minus happened because I times I is I squared, and I squared turns into a -1. The line that has I in it, the two pieces that have I after you multiply it out, I've put below. So I times, in parentheses, cosine x times sine y plus sine x times cosine y. That would be the imaginary part of our expression because it has the I being multiplied by it. The next line down, I have not done anything to the left-hand side. It's just e to the I times x plus y in a parenthesis. But I've used Euler's equation to now write that out with x plus y taking the place of theta. So that's cosine of x plus y plus I times sine of x plus y. Well, that is equal to e to the I of x plus y, and so is that double line above it. That's also equal to e to the I x plus y, which means those two expressions with cosines and sines are equal. Since those two expressions are equal, and they both have real and imaginary parts, I can set the imaginary parts equal and the real parts equal. So the two parts that are real are the parts that don't have I involved. In the bottom equation, that was cosine of x plus y. That's got to be equal to, in the equation above, cosine of x times cosine of y minus sine of x times sine of y. That is the sum of angles formula for cosine and is listed as the second to last line on our page. The bottom line, the sine version, is the imaginary part. So from our equation right above, we know that the imaginary part has just sine of x plus y. In the equation above that, it's the whole line that has the I times in front of it. It's the cosine of x times sine of y plus the sine of x times cosine of y. Those have to be equal, and that is the law of, it's the sines version of the sum of angles. Those two equations are very helpful with trigonometry, and I think I'll talk about them in another video. Thank you.